Hi guys, the next topic I'll be going through is roots of a polynomial. Let's jump straight into it. For a quadratic equation, ax squared plus bx plus c, over here, with roots alpha and beta, the sum of roots, which is alpha plus beta, is just negative b over a. The product of roots, which is alpha times beta, is just c over a. Now this may seem a little bit random to you, but the reason why this works is because ax squared plus bx plus c can be written in terms of a x minus alpha, x minus beta. Again, where alpha and beta are the two roots. And if we expand out a x minus alpha, x minus beta, we'll get ax squared minus a bracket alpha plus beta plus a alpha beta. As you can see, if we compare the coefficients, the constant coefficient, alpha beta is just c over a, and over here, alpha plus beta is just negative b over a. That's just how these formula are being derived. Similarly, for a cubic equation, ax cubed plus bx squared plus cx plus d, with roots alpha, beta, and gamma, the sum of roots, or alpha plus beta plus gamma, is just negative b over a. And next, the sum of the product of any pair of roots, alpha beta plus beta gamma plus gamma alpha, is equals to c over a. Now this name looks a little bit long, sum of product of any pair of roots, but what I'm doing is basically taking all possible pair combinations. So alpha beta, beta gamma, and finally gamma alpha. Finally, the product of roots, alpha times beta times gamma, will be equals to negative d over a. Now if you look over here, there's some sort of a pattern going on. Can you see that the sum of roots is always equals to negative b over a? And one more thing, the product of roots is always the constant term over a. In this case, c over a, and over here is d over a. And it's only negative for odd degree polynomials, such as this cubic equation over here, negative d over a. So I have this formula that product of roots for any degree polynomial is just negative 1 to the power of n, where n is the degree of the polynomial, times the constant term over a. This thing over here is just to say that for an odd degree polynomial, it will be negative, but for an even degree polynomial, it will be positive. Okay, let's solve a question. Given that x cubed plus 4x squared minus 3x minus 2 has roots alpha, beta, and gamma, find the new equation with roots 1 over alpha beta, 1 over beta gamma, and 1 over gamma alpha. First of all, this is a cubic equation, so we are using all these formula over here. What I like to do is I'll find all of these information. I'll find the sum of roots, the sum of the product of any pair of roots, and then the product of roots. So let's find out the sum of roots. Alpha plus beta plus gamma equals to negative of b over a. In this case, b is 4 and a is 1, which is just negative 4. Next, the sum of the product of any pair of roots, alpha beta plus beta gamma plus gamma alpha, will be equals to c over a. In this case, c is negative 3 over a, and a is 1. And finally, the product of roots alpha beta gamma will be equals to negative d over a. In this case, d is negative 2 and a is 1. So negative d over a is just equals to 2. Now, what the question asks us to do is to find the new equation with these new roots, 1 over alpha beta, 1 over beta gamma, and 1 over gamma alpha. Now, if we find the sum of roots, sum of the product of any pair of roots, and the product of roots of these three new roots, we can actually reverse engineer this new equation. Wait, so how do we do that? First of all, if we know the sum of these new roots, this will be equals to negative b over a. So we can find b in the cubic equation. Similarly, we can find out what c over a is, which can tell us what c is in this new equation. And finally, if we know what the product of roots is, we'll know what negative d over a is. And this will help us find what d is in the new equation. Okay, let's start. What is 1 over alpha beta plus 1 over beta gamma plus 1 over gamma alpha? Okay, this looks a bit difficult. We probably have to do a bit of cross multiplication, which is a bit complex. So let's actually simplify all of these first. how can we simplify these new roots? Well, actually, if you look at the product of roots here, this tells us that 1 over alpha beta is just gamma over 2. And similarly, 1 over beta gamma will just be equals to alpha over 2. And finally, 1 over gamma alpha will just be equals to beta over 2. So with this information, we can very easily solve for the sum of roots. The sum of roots will just be alpha over 2 plus beta over 2 plus gamma over 2, which is equals to alpha plus beta plus gamma over 2, which is this thing you have over 2, which is negative 4 over 2 or negative 2. Next, if we take the sum of product of any pair of roots, this is taking alpha over 2 times beta over 2 plus beta over 2 times gamma over 2 plus gamma over 2 times alpha over 2, which will actually give us this thing over 4. So we get negative 3 over 4. And finally, the product of roots will be alpha over 2 times beta over 2 times gamma over 2, which is alpha beta gamma over 8, which is 2 over 8 or 1/4. Okay, now let's find the new equation with these new roots. What do we do? Let's just assume a equals to 1 for now. So we'll take x cubed, and remember, to find b, we need to take the negative of the sum of roots to find b. So we'll take negative of negative 2, which is just positive 2, and then we follow by an x squared. C is just equals to the sum of the product of any pair of roots, which is this value over here. So C is just negative 3/4. And don't forget your x over here. And finally for D, similar for B, we have to flip the sign. So we'll flip the sign and we'll have negative 1/4 equals to 0. That's our equation. About our earlier assumption that a equals to 1, it really doesn't matter what value of a we get. In fact, we can multiply all of this by 4 to get an a value of 4. And this cleans up our cubic equation a bit. So that's your new equation with the new roots as 1 over alpha beta, 1 over beta gamma, and 1 over gamma alpha. Here's the summary sheet for roots of a polynomial. Thank you so much for watching. I hope you guys enjoyed.